Today we are going to present on the topic of running gRPC at scale, listen from the frontliness of production. So let's get start from the beginning, from the starting of my title. So what is at scales mean? So means handling the productions in high throughput, low latency, and high availability, multi-region deployment, and the complex service deployment. In the similar way, we have the lesson from the frontliness of the production. So what is frontliness of the production? It means it signifies or indicates that the real real world battle tested solution or incident that has happened, and we do have the solutions or solution that work for us in the real, just not in the theory. So it's focuses on the operational concern rather not using gRPC uses. So in the same way, from this talk you could assume the familiarity with the basic protocol buffers, service definitions, client server patterns, and like products and concern like reliability, observability, and scalability, maintainability, and so on. In the similar way, so let me introduce to you. My name is Sailesh Singh, and I'm from Nepal. So I'm the GNOME and Ubuntu Nepal co-lead. So active in the open source. I'm the developer and system network admin since 5+ years of experience in system network administrator. And these are my language specifically that I work on till now. And in the same way,
So, hello everyone, I am Prashubha Pathak. So, I'm currently pursuing computer engineering and I'm a highly open source contributor and maintainer. So, I have been working as a developer and a system engineer since lately, and I'm deeply into architecture, design, and deployment. I have recently volunteered UbuCon Asia 2025, and as an active contributor of Knox, I am organizing various events at my college as well. So this is it about me.
so let's again get back to our talk. So in order why this talk matters, actually why we are doing this talk, we have already have some basic sort of informations why what is gRPC. So this is the gRPC conference. So nowadays systems are expanding growing rapidly. What does that mean? Systems are going horizontally and vertically expanding in the high pace. Along with this microservices increases, similar way data volume increases, and the number of interactions between the service multiplies as well. This creates the new demands between the communication systems and the backend performance. Yeah, and due to the increasing number of the company applications and increasing number of the systems, user expect more faster, more reliable application. They want real time response, no downtime, and smooth scalability in the system. This means backend service must handle all the higher traffic without any issues and without slowing down. So we all are talking gRPC is fast, efficient, and reliable. Why it's so? Because it provides high performance communication between the microservices. Because it uses HTTP2 protocol buffers, yeah, gives the lower latency, and it's support it means bidirectional communications. So the things is everything works fine till you are in the development phase. So when you are in the developmental phase, it's work fine, but actual challenge start from the production. So running gRPC locally is easy, definitely easy. So while we are in the production, there are lots of things we need to consider. What is load balancing, retries, connection management, service discovery, observability, and much harder things are going on. So production environment introduce failures, unpredictable traffics and node restart, recovery, and many more network issues that we need to address. So we won't say we would show you the code, but definitely our what practical lessons during the time of high scale deployment, what we face the issues, you definitely do. So as it says, practical real world production lesson is what actually breaks when during the time of deployment, during the time of productions, and what actually breaks. Yeah, how to monitor the services, how to make connection draining, how to make load balancing, work with HTTP2 version upgrading, version updating, and many more. and solution of the bottleneck. So there are lots of things you find, like how to run the code, how to deploy, and many more. So official document, there are lots of official documents that you could find. So you need to know about. You can read everything from the documentation, but you also need to understand what are the pitfalls, what are the debugging strategies. Something work for me may not work for you. In the similar way, what are the architecture choices? There are lots of architecture. What architecture choices you need to like apply in the actual work, the pattern used in the real world production, and similarly. So today we have like lots of agenda. Let's make it quick. So gRPC, intro to gRPC, basically what gRPC is, slide, why gRPC at scale, service discovery, observability, load balancing, and water backward completely deployment strategy, some of the demo code, and in lesson learned.
So you have been quietly hearing about gRPC lately now, like what gRPC is, why it is used, and where it is used, how it is used. We have been hearing about this since the morning. So talking about gRPC, as we all know that it is an open source RPC framework developed by Google. Taking an example, we can say that, for example, we have an app, emails, so an efficient email system, and which we have various microservices. The microservices can be of notification services, payment services, anything. And we can see they have to communicate with each other. All those services, microservices from one end to another, and we have to communicate. But how? In this lesson, we can see how gRPC actually works. We can see that the messages from one end to another end, how they are actually being transferred, how it is, and how fast it can be. So since RPC is a framework developed by Google, it is very fast, reliable, and efficient way to transfer the messages from one end to another end without our servers or microservices figuring it out, how to send, from where to send. It is all done by gRPC. And also, gRPC uses HTTP2 transfer. What does it mean? You can simply take it as an highway, a highway where we take the road as to cut off the crowded area. It is a simple and fast way to send our messages fast and efficient way. And also, it uses protocol buffers, also known as protobuf. They are like tiny messages or letters, which are like they are combined with various messages or long message confined into a small space, which is like small information is equal to faster data transfer. So this makes it more faster and more efficient. So all of this used by gRPC is mainly designed for high performance microservices, which actually makes the system and gRPC more efficient, more faster than any other things. So also, why HTTP2 plus a protobuf? We have heard about how they work, but why only them? So you can see HTTP2 is used for sending messages from one part to another part, one end to another end. So how does it actually work? So there comes the concept of multiplexing, many requests on one connection. That is, we can send various messages from one end to another end at the same time or different time, in both ways at the same time as well, without any blocking, which makes it really fast. We can, without any blocking, our system will become more efficient. And also header compression hatchback. This basically does shrinks the header messages, which makes it faster and smaller in part to communicate very easily. Also, binary serialization protobuf. Protobuf has a concept of binary serialization. As we send our messages in tiny little packs, it is converted into binary code, which is more lighter and faster while transferring. Also, protobuf supports strongly typed contracts. That is, it is clear that what server and client are expecting the data. They know what to expect and how they are sharing the data. So all of this combined gives low latency, high throughput, that is fast response and many request handling at the same time.
So here comes the service discovery. So service discovery means we do have like lots of microservices and dozens of service, even hundreds of services going on, and need to communicate to one another at a time to ensure that where to communicate. So during time of service discovery, where to communicate, where one service communicate to another service. So that may be like even as IP in the form of IP pods or nodes, anything can be happen. So we have DNS discovery. So with a simple DNS based discovery, like we can resolve the host name like certain like we would say like my service something into like a certain IP address, then that IP address into the available instance we can map. This approach is easy to implement, but it work only for the small instances or small or medium steps. So DNS comes with a like bit of limitations like catching that delay, or it is not ideal for like scaling, for rapid scaling. If you say rapid scaling, it won't like work actually, like because we do have DNS catching and slow propagation for new pods and many more. So there comes like Kubernetes service discovery. So it have Kubernetes has a built-in service discovery mechanism. That what it does is that creates service like cluster IP, node port, load balancer, and it does automatically, which like assigning like stable virtual IPs, track pod IPs, and route traffic through like proxy IP tables. In the similar way, it updates the destination in points, time, and often when pods die or when pods start. This allow to connect to like consistent service address through like dynamic pod lifecycle behind the scene. So we do have a service mesh. So service mesh provide like sidecar proxies. Service mesh gives you like sidecar proxies. It means like they add features like intelligent load balancing, automatic retries and timeout, circuit breaking, zero trust security, MTLS encryption, and in the similar way traffic like shipping. So you guys must aware of the sidecar proxies. Like we keep same thing side by side, and if one is back, we like work with the another one side by side. So it has to balance. So the challenges here come is the dynamic pods scaling and the restart. So what does that mean? So in the modern system, like services are always challenging, changing, time and often changing. So new pods get created and the older one get dies, and nodes keep on restarting. Deployment like got gradual rollout, gradual roll in, container crash and recovers. So in order to manage this in the gRPC, it's more challenging because gRPC uses HTTP2, which is the long-lived connections. Yeah, HTTP long-lived connections. So in this case, like if the client hold to old connections, there is chances that they could send traffic to like dead pod, unhealthy pod, or the training pod. So this result in the failure.
So talking about observability, you know, every system in this whole world, we need to observe things. It's about monitoring whatever we have made for a convenient and efficient system to work on. We need to check how the system is working. It is all about observing, because you can't fix something which you can't see. So you need to see and check first if the system is working properly or not, or how it is. So there are various parts from which we can observe our system. For example, structure logging. So if we use the concept of structure logging, which is like maintaining everything, our logins and everything in structured way, which is very easier to debug, which is easier to update, modify anything, so which will be more easier to observe our system. And next is matrices. So they are like a number used to show our system's efficiency. So you can see P50 latency. It's like the slowest, it's like the normal speed for the users, and similarly P95 is slower than P50 in our users while sending messages and all. And P95 is the worst case, in which we can see the worst case where there may occur errors and all. Error rates are also something when they face when there are the system failure. Also tracing with Jaeger and Jipkin, which is like seeing our path, like how the messages are traveling, how the messages are going in which path and all. So in this way we can observe our system.
So P50 works with the like user side of like P50 like latency work with the like user side of experience. P95 for the like some of the having high features, high requests like it may be admin, super admin. So this type of latency can be seen on the P95, and P99 actually occurred on the like production side, which is like worst case type of latency that hides the like lot of things which we can't find in the time of the productions. Later on, we have some of the demo code for the gRPC interceptors. So you can see the code like it says like it is the production logging metrics which measure the latency, extract the trace ID, process the Prometheus metrics, and structures JSON logs. So how it does, why this interceptor metrics, why this interceptor matters. So in the real world production pattern, you will find the most serious gRPC deployment, and it is because it is the act as the middleware between like every request pass through it and before reaching your service logic. So you could make the perfect. This is the perfect place to add the cutting features such as like latency measurement metrics, and structured logging. So in the simplified way, if we talk about measuring the latency, like there is like you could see the start time dot now that record like initial time, it will detect the initial time, then after it will like record after like its whole duration, then after we extract the trace ID, that could you could see the block of code starting with if, that block of code starting with this, that like that extract the metadata incoming context like trace ID, and it often the carry or trace ID API gateway or service mesh. So these are the things, and it later on pushes the products. It pushes the Prometheus metrics. So we have like request latency in the, you could say in the here like Prometheus matrix. Prometheus, you could like see measure how long each method takes to, and it explains the two metrics along like RPS, P50, P95, and P99 latency, and the per method log. In the similar way, we have a structured JSON log. So we have log.printf, which is showing the some of the printing method that you guys can find that help to like print in the like JSON format, not in the plain text, that it insert the compatibility with the centralized log system like Cloud Search, Elasticsearch, many more. And it helps to like filter logs by like gRPC ID, gRPC method, duration, and many more. In the similar way, we have load balancing. So let's make it a bit short. We are running out of time, I can see. So it's a load balancing. So we have three things. We client side load balancing round. I have kept round robin, but you could. What is client side load balancing, or simply what is load balancing? So in the client side load balancing, we like directly pick which in this round robin, which directly we can directly pick which backend stack we need to talk to, or clients receive a list of backend endpoints like via like DNS, XDS, or service discovery, and then it select a server using policies like I am using, for example, round robin. You could use like pick first or weighted many more like that, and it advantage of it is that it uses fewer hop, and which leads to lower latency. But drawback is like client must continuously resolve the backend or risk of sending the traffic to still state. So in the other is we have like proxy load balancing, that we have Envoy and Nginx. So many production set up a place like proxy layer in front of the gRPC, yes, gRPC service, yeah. So Envoy and Nginx both support the HTTP2, while gRPC load balancing supports the load balancing. And benefit is that it like simplify the code for the client. It means that client only have to request to the server, centralized connect. It has centralized connection management, better retry, and timeout control. And yes, we have next one is service mesh load balancing. So service meshes Istio and Linkerd, I heard like Istio and Linkerd. So it also offered advanced load balancing behavior out of the like box, like traffic splitting, na, circuit breaking, like retries with the backup, yeah, and automatic MTLS. These are the thing, and it let you control the load balancing without touching the application code. So here the challenging is HTTP to long live connection, which led to the hotspotting. What does it? So this is the most important point on this slide, because like we are using the HTTP2, which is like more persistent, which is like long connection. For example, a client may open one connection and send 1,000 millisecond RPC through it, and if one backend receives the more long-lived connections, other it become a hotspot for others. So it leads to uneven CPU uses, more memory, and unpredictable latency that you can't find out an imbalance if traffic look balanced or many more. So we can do like its solution by connection pooling and periodic connection reset and many more, and using XDS aware of gRPC clients. We have a bit of demo code here over here. So load balancing and the retry. So this load balancing and retry code is actually the actual code, real production ready client code. So not just a simple example. So how it handles is like we can see like there is written like there is dialing up the connection your gRPC. There you could see prefix DNS, which state that we are using DNS based discovery. Then after we using the round robin is the policy, which means we are using the robin policy. And you could see like my service is nothing but inside the Kubernetes. You set up using the DNS resolver, yeah, connected to my services, maybe the pod or something. So it helps in the like round robin helps in this case the round robin helps in the client cycle through each backend endpoint and avoid the distribute the request evenly. And another one is retry and exponential backup, and it is necessary. Exponential backup and retry is necessary in the context of the gRPC and many more codes, because you may lead to, if your code doesn't work properly, you may lead to infinite number of requests. You would be in the deadlock condition if you want to manage it properly. So for example, I'm in retry policy with a maximum attempt of for that led to client up to 4 times if packet is unavailable. Initial backup is 0.2 second. So first we try wait for 0.2 seconds. Similar way backup multiplier 2 means for each try each multiply by 2 times, and the number is back. There is backup max backup 2 seconds. It means request retry wait time until exceed 2 seconds, and if it won't find anything, then it would respond unavailable, and this prevent like cascading failure, or we could say retry storm I already mentioned. So you could say why it is important. So like you guys have already understood why it is important, because load balancing and retry together is important for better availability, smoother handling of the pod crashes, and the automatic failover between the backend instances. This is the foundation for the like resilient gRPC clients in a microservice environment.
So let me make this real quick. So backward compatibility, what it means is, since we are adding new features to our system, our old clients might not get used to it. So they are using the old system, but we have upgraded up to new versions. So here comes the main problem of backward compatibility. So making changes to our system may not suit our previous clients, the clients which have been using our system. So safe changes, there are some safe changes which does not affect our client's user experience. They are like adding fields. If we add new fields to our system, the clients will be using our own their own old fields, so there will be no problem at all. Also adding methods, if we add new methods to our system, our old clients will be calling the old methods only, so there will be no issue at all. And also add enum values. The older clients will be asking them as unknown, and this will be no problem at all. But there are some breaking changes which, if we add to our system, may disrupt our clients' user experience. They are removing fields. If we remove some fields which our old clients are using, it might hamper their experience. And also change field types and numbers. If we change something like that, our clients using that may hamper their experience as well. So strategies for these breaking changes, so strategies for adding new versions are maybe versioning. That is, if we are in version 1, we can upgrade our system to version 2, while our old clients may use version 1 as well, and you can go to version 2. And depreciation as well. If we are adding some changes to our system, we can depreciate that without first giving some hints that our system is going to change and all. And also feature flags, that giving them already some notifications that our system is going to change, and this is how we can do backward compatibility.
So here comes the deployment strategy. I won't be mentioning like why deployment strategy is challenging because yeah. So like in this we have like two identical like strategy. We have identical strategy like blue green deployment strategy. In this like blue for the current production and new version is for the like green. In the similar way we could do easily rollback, no partial updates and many more. In the similar way we have canary rollout and another one is rolling update and the other is connection training. Connection training is important because this is extremely important because when pod is about to shut down, it should like at least stop accepting the new connections and let and wait for active streaming call to finish. If it is not the case, if we are using the like Kubernetes and it has pre-stop hooks and if you don't bring the connection, you will break the client side, especially like many more. And we have gRPC consideration timeout training readiness probes. So you guys are aware of it, I believe. So liveness probe check the duration and the readiness probe check either it is ready to accept the connections or not.
So these are the lessons learned. We are completely aware of this. Observability first that we should observe our system, monitor it regularly. Start with simple programs, simple system which is easier to debug and update rather than getting into a complex one. Test failures. Even if your system is working very well, test the known failures. Test very. Test the failures, then manage connections. You should use the connections for our better use of the system and better health. And also timeouts matter. Keep timeouts to every single thing. You are if it take long time, our system may crash out. So this is why all this matter because it actually avoid the pitfall, improve the reliability, and it help you in the adoption of the gRPC like in a strong way, and it also benefit the open source ecosystem like when developers sharing learning their toolkits, and it elevates the entire gRPC and add cloud native ecosystem and communities like GNOME, Kubernetes, and Linux similar way. And I think this is the end of the slide. And thank you so much, guys. We are running out of time. Thank you.